hopefully you guys are good with this, as well as if you have to do the personal project today, hopefully this isn't too much for you guys. Hopefully you've worked on that personal project enough in the past to be comfortable. So let's take a look real quick. If you look, we want to finish periodic trends. And then the answers to the review are there. So if you click on here, you can get all the answers to the review. Tomorrow, what I suggest you do tonight, if you have personal project presentations, then just skim over it and then come in with questions tomorrow for topics you don't understand. Like you should be able to sit there and read through and be like, oh, I don't understand that necessarily. Put a star next to it. Make sure you bring those questions tomorrow. That way we can answer them. And then you can check the answers to all the stuff you do know over the weekend, because the answers are here to the review. If you click on that, you can get all those answers to all the reviews. Cool. Let's take a look and get this page done then today, and then I'll let you guys go. All right. So yesterday we talked about how nonmetals have a lot of electrons, but they have also a lot of protons in the nucleus. So they pull those electrons in tightly. That means that they gain electrons. Metals generally have less electrons, less than 4, but they don't have a lot of protons in that, their electrons from the last energy level are further out there. So I should say that they do have protons, but there's not the last electrons in the valence shell are definitely extended out there. So the group described by P4. Well, we got to find P block 1, 2, 3, 4. They would tend to take a charge of -2 because they have 6 valence electrons. They want to gain 2 to get 8. What is the name of the group described by P6? 1, 2, 3, 4, 5, 6. This last group out here, we called last semester. Hopefully you remembered that. We called them the noble gases. What fills first? Well, you could write out your sequence up top, your alphabet sequence, or you could just go with the periodic table, 7s, 4f, or 5d. So 4 is the lowest number. So I'm going to start with 4s, 3d, 4p. 5s, 4d. Was that one of my choices? Nope. 4d, 5p. 6s, now notice 54 to 50, I'm sorry, 56 to 57. 6s, 4f. Oh, there we go. 4f was the first one I came to. Next one, 4d, 5p, or 4f. So again, 4 is the lowest number. 4s, 3d, 4p. 5s, 4f. So 4f was the first one I came to. What takes less energy, 6d, 6s, or 4f? These are exactly the same questions. I'm going to do them the same way. So 4 is the lowest number I heard. 4s, 2, 3d10, 4p6. 5s2, 4d10, 5p6. Not reached any of them yet. 6s. There we go. 6s comes first. Group 3A likes to take a charge. Here's group 3A. They like to take a charge of 3. And they're described by the letter in superscript. Well, this is 3p, or this is 3p, p1. They like the p1. 5A likes to take a charge of, here's 5A. They like to take a charge of -3 because they want to gain 3 electrons so that they get 8. And have blank dots. Well, this isn't something we talked about before. So today we're going to talk about it. Here's nitrogen. This is actually our next unit. It's going to have 5 valence electrons. So we need to give it 5 dots for what we call the dot notation. 1, 2, 3, 4, 5. And basically you put dots on each side until they're all filled up, and then you give the next one that you put on will pair up with one that already is there. And since we have 4 sides, the maximum we can get is 2 on each side. 2 times 4 is 8. And that's what we call the octet. That's why 8 is the octet. I'm sorry. Are you just watching on? It is also described by the letter in superscript. So if we take a look, here's nitrogen, P123, P3. Questions so far? All right. Next part, they give you the element, you give them the last of the electron configuration. So if we take a look, radon is here. That is 6p, 1, 2, 3, 4, 5, 6, 6p6. Erbium is down here. Remember, the F's are always 2 behind, so that's 4F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4F12. Scandium, the D's are always 1 behind, so it is 3D1. Iodine is here. That is 5, 5p, 1, 2, 3, 4, 5. 5p5. Iridium, right here. That is 6, but the D's are always 1 behind, so that is 5D, 1, 2, 3, 4, 5, 6, 7. 5D7. Next one, number 12. They give you the numbers and they want the element. So 6s2, 6s2, barium. 5d8. So here is 6s. The D's are always 1 behind. So this is 5d, 1, 2, 3, 4, 5, 6, 7, 8. Platinum. 4p5. This is 4. 4p, 1, 2, 3, 4, 5. Bromine. 5f3. Hard to see. 5f3. Here's 5f, 1, 2, 3. Protactinium. 47. Here's 5s, 4d, 1, 2, 3, 4, 5, 6, 7. That is rhodium. Right, the shorthand electron configuration here we have tungsten. So we find tungsten on the periodic table. We find the noble gas that's right before it. That is xenon. Put brackets around xenon. Xenon, after xenon is 6s2. Then we got to go down here. 4f. How many are in F? How many can an F hold? S can hold 2. P can hold 6. D can hold 10. How many can F hold? Nobody knows. Oh no. Well, let's count them. You can count, can't you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 4F14. Then we go back up to 5D, 1, 2, 3, 4. 5D4. Iodine. Iodine is here. So we go to the noble gas before it, which is krypton. After krypton, we have 5s2, 4d10, 5p1, 2, 3, 4, 5. Boom, boom, and that's how we do that. All right, the last thing we need to talk about here is what's called the ionization energy. And we've discussed ionization energy. We discussed it yesterday. We said that ionization energy is the energy required to remove an electron from an atom or ion. From an atom or ion. We likened this to taking candy from your younger sibling on Halloween. Which candy is the easiest candy to take? It's the candy that's furthest away from them. If you can distract them, it's better. But here's the key thing. If they suspect you of taking their candy, what are they going to do? Seth, do you have any younger brothers and sisters?
Pull their candy in closer.
Christian, beat you to it. Seth, do you have any younger brothers and sisters?
Yeah.
Yeah. Have you ever stolen candy from them?
Yeah.
Monster. No, I'm just kidding. What do they do? Do they hit
They take
you?
mine.
1, 2.
They take one of mine.
They take one of yours. Unfortunately, atoms are not set up to be able to do that. So as Christian said, if you take an electron from an atom, it's going to pull all of the rest of the electrons in closer. That means subsequently, it's going to be more difficult to take another electron, right? So we call the energy required to take an electron ionization energy. The first ionization energy is the energy required to take one electron. The second ionization energy is the energy required to take an electron after you've already taken one electron. So the ionization energy, the second ionization energy is the energy required to take a second electron. Well, here is the cool thing. Let's go back a little bit to the notes and we can look at these ionization energies. So to take an electron from sodium, that'll cost you about 495 kilojoules. But to take a second electron from sodium, that's going to cost you 4,562 kilojoules. That's almost 10 times more. It's actually 9 times, about 9 times as more energy to take a second electron. That's not always that way. 740 kilojoules to take the first electron away from magnesium. 1450 to take the second one away. But if you want that third one from magnesium, it's going to cost you about 5 times more energy. And then even more if you got that one away and you wanted to take another one. For aluminium, though, it's about 600 kilojoules for the first one, 3 times more for the second one, and then less than double to take the third one. But then, boom, we're looking at 3 times more again to take the fourth electron. So if we look at this, sodium has 1 valence electron. It is in group 1A. So it can lose that first electron, but it's not losing any more after that. Magnesium is in group 2A. So it has 2 valence electrons. So it can lose 2, but it's not losing any more after that. Aluminium is in group 3A. Here's the thing. If you're in group 7A, we said your ionization energy is so high, there's no way you're losing any. Instead of losing any, you're going to gain one. Right? So these are the first, second, and third ionization energies for these 3 elements. Let's see if we can figure out by doing one of these problems. Let's do this problem right here. Given the following successive ionization energies, how many valence electrons would this atom have? Well, we're looking for a big jump in energy requirement. If you had $100, would you be happy? How much would $200 make you? Would you be like, blah, I'm quitting everything. I got $200. Probably not. Be like, oh, I still got to do crap. But $400, is that enough to make you be like, what? Well, this is not that big of a jump. How about $650? Still, that's not that big of a jump. If you were making $400 a week and all of a sudden you made $650 a week, you might be like, yeah, I did pretty good this week. Let's say that 1 week you come in and you make $31.80. That's a big jump. Right there, that's a big jump. If you were expecting a $650 paycheck and all of a sudden you got $3,180, you'd be like, oh, right? And I'd be like, woo, like your head comes off, the top half like goes up, and your ears have steam coming out of them. That's a big jump. So right there, we're looking at this right here, guy, being the last easy electron to take. That's the last of their low ionization energies. So what that tells you is that this has 1, 2, 3, 4 valence electrons. That element is somewhere probably in group 4A, probably either tin or lead, right? Now you do one. Here are the successive ionization energies: 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Where's the big jump? Is it between 1 and 2, 2 and 3, 3 and 4, 4 and 5, or 5 and 6?
1 and 2.
1 and 2. It doubles. Is that the biggest jump, though?
I can't see them all. Your pen's in the way.
Oh, my pen isn't blocking the ones you need to see.
Oh.
2 and 3.
Yeah, right. Take a look. $1,450 you're making. All of a sudden, boss man says, "Hey, you got a paycheck of $7,700 this week." You would be like, "What?" Right? It's almost 5 times more, right there. You'd be like, 5 times increase. What? So that means that this thing has 2 valence electrons. Can anybody tell me if this is a period 3 element between sodium and argon? Which element in period 3 has 2 valence electrons? I don't even need to show you more of period 3. Which one is it?
Magnesium.
Magnesium. You are exactly correct. Very good. It's magnesium. All right, guys, that is the lesson for today. I do hope that you use the rest of this period, and I'm not saying spend a huge amount of time, but go down through there and put stars next to questions that you know that you need to review and that we can talk about tomorrow. All you got to do is go down through there real quick for 5 minutes before the end of the period. Mark the ones that you think that you need to talk about tomorrow. That way we can do that. Otherwise, you have the answer to all of the questions. If you know something, you don't have to review it. You can answer it and then check the answer over the weekend. The test on this is on the asynchronous Monday. So tomorrow will be the last point that you have questions. And if you email me over the weekend, like the weird thing is I may be driving and I may sit there and click on it and then it's out of my head. Like the best time to contact me is right after these Zoom meetings and stuff like that, because it's hard whenever we have students here sometimes because they have needs as well. But like if you email me at 9 o'clock at night, it is hard for me to sit there and remember that stuff because that's right before my bedtime. So I'm like, what is this? Oh, I'll handle it tomorrow. Oh, hi, whatever's in my dreams, right? Have a great day. We'll see you guys.
Did you already talk about the format of the tests?
It's multiple choice.
Okay. Okay, thank you. Wait, but
Does
what
that make
about
you
like,
happy or sad?
huh?
Does that make you happy or sad?
Happy because like when the other one, the gas test where we had to put our answers, like you didn't really know if you were on the right track or not.
That was
So
tough.
it just makes it easier to know what you're doing. Thank you.
You're welcome. All right, Lauren, what are we looking at? I know that you needed to talk to me.
I needed help on 2A and number 3.
Number 3. Of the homework you did last night.
Yes.
So this isn't right. What? This isn't 2A. You have to help me out. I don't know what. I don't know what.
Actually, I meant like the what's it called, the quiz.
The quiz. Okay. Let me see here real quick. That deals with the math problems, right? So what
Sorry,
was
what'd you
2A
say?
asking you?
It says which has the higher potential energy, the third level or the second level.
Okay. So if here's our nucleus, excuse me. The first level is here. The second level would be here. What did we say? As you get away from the nucleus, which one has more energy? Closer to the nucleus or further from the nucleus? We even said if you're swinging a baseball
Further.
bat, if you're swinging a baseball bat, where is the energy at? At the end of the bat or closer to your hands?
End of the
End
bat.
of the bat, right? So further from that center point is higher energy. What's the next?
So third level.
Well, is that the higher one? Is that the one further away from the nucleus?
It says third level. Oh, it says the third level is negative 2.4 times. Does that have something to do with it?
You can do that. What does it say about the third level? Negative what?
Negative 2.42 times 10 to the negative 19 power.
And what
joule.
does it say for the second level?
Negative 5.45 times 10 to the negative 19th exponent.
So you could also look at these two numbers and decide which one is closest to 0. And that would tell you which one is greater as well. So there's two ways to do it. Whichever one is furthest from the nucleus is going to have the higher energy. And whichever one has the number that's closer to 0 here is going to have the higher energy. What's closer to 0, -5 or -2?
Negative 2.
There you go.
And then I also needed help on number 3.
Will you read it for me?
It says, as an electron moves back and forth between the fifth level and the second level, a photon with an energy of 4.58 times 10 to the 19th power joule is involved. What is the wavelength of that photon in nanometers?
Yep. So you're given the energy of that photon. So you're going to use this formula right here. You want to solve for this. You're going to solve for the wavelength, right? So you have this energy. You have Planck's constant and you have the speed of light. So you need to solve for lambda. Now the thing is that you're going to end up solving for lambda and getting meters, right? So you'll have meters. Every 1 meter is equal to 1 billion nanometers. So you have to times that by 1 billion. And we did that on this problem right here, actually. That's where we actually did that problem. Actually, both of these problems dealt with it. Tamara? Or Namara?
It's Namara. You said it right the first time. So I just had a question about the other quiz, but like I know there's other students, so like when's another time I can come back?
Right now. Let's go ahead now.
Oh, we can talk about my quiz right now.
That's what
Okay, but
that's what Lauren and I are talking about, right?
yeah, but it's not about the one we just did. I think I did pretty well on that one.
Okay, is it about the 1S2, 2S2 stuff?
I don't know. Let me check.
Seth, did you have a question or are you just hanging out for better information?
As I kind of forgot what my question was, so I'm just hanging out now.
Okay, all right. If it comes to you, by all means.
All right.
So if it's on this stuff, I mean, like the biggest part of that I could see you guys having trouble with is something I asked today and nobody answered me, but it's this right here. Like you need to know that an S has one orbital, which can hold 2 electrons. It doesn't matter if it's a 2s or a 5s or a 20s, it still has one orbital, and every one orbital can hold 2 electrons. A P has 3 orbitals. It doesn't matter if it's 3p or 5p. 3p is just closer to the nucleus than 5p, right? But it still has 3 orbitals. Each orbital can hold 2 electrons. All orbital means is there's space there. It's a set defined amount of space.
Wait, you said each orbital can hold how many? 2?
2, right?
So it doesn't matter if it's like S or P or D or F?
Each orbital can hold 2. The difference is that S has 1 orbital, P has 3 orbitals, and D has 5 orbitals, right?
So like how many electrons can a 4D orbital hold? Wouldn't it be 10?
No. 4D has 5 orbitals. All 5
Right,
orbitals, all 5 orbitals could hold 10. One orbital here, just one can only hold a maximum of 2. So this is an orbital, but 4D has 5 of these. It's like having a jewelry, it's like having a jewelry box with 5 drawers. Right? It's one box, but you have 5 drawers that you can store stuff in. Let's say each drawer can hold, let's say they're tiny drawers and each drawer can hold a pair of earrings.
Well, then I'm confused how it can't be 10 if there's 5 orbitals and each
Can, but you specifically said a 4D orbital. If you were talking about this whole thing, you would call this a 4D sublevel.
Oh.
See, the difference is remember we were talking about the jewelry box. You're thinking of the whole jewelry box. I'm talking about one drawer on the jewelry box.
Oh, okay. Oh, okay. That makes so much more sense. So because you specifically said 4D,
Orbital
oh,
is the key. Orbital is just one of these boxes, right?
yeah,
Yep.
that makes sense. I'm looking for what else I could have missed.
All right. Lauren, how are you? Are you good?
Yeah, I'm just solving the problem now.
Okay, cool. Seth, did it come to your mind? Do you have any idea of what it was about? You good? Is your hair usually that long or are you just growing it out for the COVID? Yeah. Yeah. This is probably the most hair I've ever had, but this is the most bald I've been too, because I'm kind of like in this getting old stage. So my hair's longer than it's ever been, but it's starting way back here in my strong forehead. My forehead game's getting tougher.
Wait, is it possible for you to like say the answers of the other quiz so I know if I got them right or wrong? I turned it in already, but I don't know if everyone else did.
I don't know. Has everybody else turned it in? What's he do? Does he cut it backwards or comb it back? Slicks it back. Excuse me. All right, you're talking about the electron structure quiz.
Yeah, I am.
Didn't I grade this already?
Yeah, you did, but like it just said my grade, so like I didn't know what I got wrong or right.
Oh. Turn 3. Oh, that's not too bad. Ah, yeah, you're exactly right. That's what you got wrong. How many
Oh wait, I see the feedback. I see the feedback.
Yeah,
It says I got 6 wrong, or not 6.
6.
Number 5, but my answer was 6.
Oh, okay. It
Can you explain that one a little bit more?
looks like I mismarked that one, huh? Oh, wait, no, I didn't. How many electrons are outside the nucleus of a sulfur atom? So that's not saying how many valence electrons there are, which is the number you gave me. It's saying how many electrons does sulfur actually have.
Well, wait, is that coming out of the periodic table?
Yep. Or you
Oh.
could just read the question. A sulfur atom has 16 protons in its nucleus. How many electrons does it have?
16.
Yeah, right.
Wait, so if you tell us the number of protons, that means that it has the same number of electrons?
Yeah, if it's an atom, the number of protons is equal to the number of electrons. But the next question says, how many electrons are there in a sulfide ion? So you had to take, that's so funny because you then had to take the 16 and add 2 to it. Right?
So it just depends. If it's autumn, it's the same numbers of
Neutral.
protons.
Because it's
But, huh?
because it's neutral. So the number of protons equals the number of electrons.
But then ions is when we have like, because it has the S2 minus, so if it has a 2 minus or any other number, that's when we have to add, right?
If it's minus, you add. If it's plus, you subtract.
But that's when it's ion.
Yep.
Okay.
You're welcome. Lauren, what do I need to put in for you? Gas law?
Yeah, that, and I feel like it's like a few other things, but I don't think you might have not put anyone else's.
I don't think I put anybody else. I didn't put anybody else's in for that grade yet either. So if it's that, then yeah, I'll get that probably this weekend. Just with personal projects and everything going on, it's been busy. Let me put your gas law in so that you can see where you're at. Last name. All right. Okay.
Thank you, Mr. Jackson. Have a good day.
Hey, you too. You had a big improvement on that test, didn't you? Nice job, Lauren.
Thank you. I actually have a question
Yep.
about number, like the exponents part, where it's like after the times 10. How would I solve for that?
Help me out. What is the question asking? Is it going from
Number
meters to nanometers?
The one that we were just talking about on the.
You're having trouble going from meters to nanometers? Is that it?
I'm having trouble figuring out, like, would I like do something with the exponents?
So what did you get for your answer?
I got 4.34.
4.34 times 10 to the what?
That was the part I was trying to figure out. The
What is the
what I put.
calculator say?
Sorry, what'd you say?
What does the calculator say?
Sorry, can you say it one more time? I think my
Yep,
internet
no worries.
broke out.
So what did you put in the calculator?
I did 6.626 times 3.00. I divided by 4.58.
All right, so you had to take it times 10 to the negative 34th, right? That's Planck's constant. Did you put that on there?
No.
Okay, that's why you don't have the times 10 thing that you're asking about. And then you multiplied by 3 times 10 to the 8th. And then you divided by a number that I don't know. You'll have to read that to me.
It was 4.58.
Times 10 to the what?
Negative 19.
Boom. So since you didn't put those things in, you got 4.3, but you didn't get 4.3 times 10 to the negative 7. And that right there is the number of meters. So you got to make sure that you multiply that number by 1 billion.
Thank you, Mr. Jackson.
You're welcome, Seth. Have a great day.
You too.
Good luck. Are you doing personal projects tonight?
Yeah.
Yeah, have fun with it as much as you can.
All right. Thank you.
Yeah, see you, man.
So what I still need to multiply it by 1 billion, right?
Did you get this number 4.34 times 10 to the negative 7?
You said 4.34 to negative 7.
Times 10 to the negative 7?
Yes.
Yeah. So then that's in meters. So every 1 meter is 1 billion nanometers. So if they want the answer in nanometers, then yes, you would have to multiply that by 1 billion.
So I would just do 4.34 times 10 to the ninth power.
Nope. You would take 4.34 times 10 to the negative 7th and then multiply it by 10 to the 9th. Because 10 to the 9th is 1 billion. So do you see what I have here? Did you get this number?
Yes.
Yeah. So then we multiply it by 10 to the 9th. That's 1 billion. Boom. I'm gonna spray these stuff down real quick. Are you doing this for today? Are you excited at all? No, I'm gonna do it up there. Probably back there. We got some visitors yet? Not yet. Oh, okay. that get it for you, Lauren? Lauren?
Yes.